All right, lesson 4.6 is, 4.6 is the quadratic formula. Now, this is a great method. It's kind of an end-all, be-all when just about all the other methods won't work. It's also a great option because here's the options that we've had is we've solved by factoring. And remember, whenever you solve by factoring, you've got to have both the bx term and the c term in order to factor. Okay. The next option we looked at was solving for square roots. And whenever we're solving for square roots, the option that we need to look for is, remember, we can only have the x squared term. Okay. We cannot have any bx term in there. Otherwise, we can't do it. And then the other option we looked at yesterday was completing the square. And remember, when we're completing the square, the option that we can have is this will work on all problems that the previous ones don't work on. Okay? All right. Another option to that is the quadratic formula. And the quadratic formula is, now remember, in our original form, ax squared plus bx plus c. And it's going to have to equal 0 when you're solving this. So all you're going to do is you're going to take your b term, you're going to find the opposite of that. So if it's a positive, you're going to turn it to a negative. If it's a negative, you're going to turn it to a positive. This sign here represents plus or minus, so it's going to be negative b plus the square root of all this, negative b minus the square root of all of this. Okay? Then you take the same b term, square it, minus 4 times the a term times the c term, and it's all over 2 times the a term. Okay? So let's take a look at let's take an example. Let's take a look at this. Okay? So remember, quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Okay? So when we're solving this, it's just a matter of plugging in and finding the answer. So remember, this is our a term is going to be 1. This is our b term, and this is our c term, and it's already equals to 0. So this is b is negative 4, so I got to turn it to its opposite and get a positive 4. It's plus or minus square root of b is negative 4, so when you take negative 4 and square it, you get 16 minus, and then it's 4 times 1, which gives you 4, times 3, which is 12. Okay? So remember, 4 times 1 times 3. And then the bottom is just 2 times 1, which is 2. Okay? And when you're simplifying this, x equals 4 plus or minus 16 minus 12 is 4 all over 2. Okay? And since we can find the square root of 4, 4 plus or minus square root of 4 is actually 2 all over 2. So our final answer is x equals 4 plus 2 all over 2, or 4 minus 2 all over 2. So 4 plus 2 is 6, divided by 2 is 3, or 4 minus 2 is 2, divided by 2 is 2. So our answer could be 3 or 2. Okay? Oh, sorry, wait a minute. I messed up. 4 divided by 2 is 2. 2 divided by 2 is 1. Okay? And when you check, remember, if we factored that, yeah, 3 times 1 gives us 3, and when you add them, we could get a negative 4. So that method would also work. Okay? So let's take a look at another example. Okay? This is 9x squared plus 6x minus 1. So when we're looking at this example, we've already got y equals 0. So remember, negative b plus or minus square root of b squared minus 4ac all over 2a. So when we're looking at this, x equals negative b, so it's a positive 6, so I'm going to turn it to a negative 6, plus or minus square root of b squared is 36. And if I find that 4ac, remember it's 4 times a is 9 times c is negative 1. So 36, so I get a negative 36. Remember, I have to change the signs, minus a negative. And then 2 times 9 gives me 18. Okay? So x equals then negative 6 plus or minus square root of 72 all over 18. Now remember, 72 is not one of our perfect squares. So when we're solving this, we need to make sure and simplify. All square roots should be simplified. And I find out that it's 36 and 2. Well, I can find the square root of 36. The square root of 36 is 6. Square root of 2. Okay? So I'm just going to break this up. X equals negative 6 plus or minus the square root, the square root of 6, square root of 2, all over 18. Okay? Now, I cannot simplify anything that's under the radical already, so the 2 is just going to have to say square root of 2. But anything that's not a part of the radical, or not under the radical, I should say, I can simplify. So you need to ask yourself, is there anything that I can take 6, 6, and 18 and divide it by? And that would be a 6. 6 divided by 6 will go evenly. 6 divided by 6 will go evenly. And 18 divided by 6 will go evenly. So your final answer, since I can't simplify this like I did the previous one, negative 6 divided by 6 gives me a negative 1, plus or minus. 6 divided by 6 is 1, so I'm just going to write square root of 2. And 18 divided by 6 gives me 3. Okay? So you might see your answers, you can leave your answers like that. You also might see your answers as negative 1 plus the square root of 2. Just remember that there are two answers. There's the plus one, and negative 1 minus the square root of 2 all over 2 as your final answer. Okay? It does have two answers. All right. On the next example, so let's go ahead and do this example, okay? And as we quickly see, it's already equal to 0, so we do negative b plus or minus the square root of b squared minus 4ac all over 2a. So, x equals negative b again. Our b term is 3, so I'm going to turn it to its opposite, which is a negative 3, plus or minus square root of b squared is going to be 9 minus, and then I get 4 times 2 times 5. Well, 4 times 2 is 8. 8 times 5 is 40. So I get 40 all over 2 times 2, which is 4. Okay? All right. So then x equals negative 3 plus or minus 9 minus 40 is going to give me a negative 36. Now remember when we talked about these, I'm sorry, not a negative 36, a negative 31. Okay? And remember when we talked about these, we mentioned earlier when we were talking about complex numbers that occasionally you will get a negative that ends up under the radical sign. So remember, anytime I want to pull that, I always have to pull that negative out. So that negative 1 turns to an I, and it ends up being the square root of 31. And since the square root of 31 is a prime number, I can't simplify it anymore. So it's going to be negative 3 plus or minus I square root of 31 all over 4. And that tells us that it's an imaginary number. Okay? And again, you might see it written on a test or a quiz or even on some of your quick checks as, negative, let's start over again, negative 3 plus I square root of 31 all over 4, or negative 3 minus I square root of 31 all over 4. Because remember, we will have two answers on these. Okay? All right. Last example is this one. And the only difference in this one is make sure that it has to equal 0. So you minus 99 from both sides, and x squared minus 9x minus 99 equals 0. Okay. Remember, on all of these, on factoring and on the quadratic formula, you have to set it equal to 0 before you can solve it. On solving equations, you're going to have to get the x squared term all by itself. On completing the square, we're trying to get this trinomial to be a perfect square. So whatever method you choose, you're going to have to remember that sometimes you're going to set it equal to 0, sometimes you're actually going to have to solve it. Okay? So remember, our formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? So x equals negative b is going to be positive 9 plus or minus the square root of b squared. Negative 9 squared gives us 81 minus, and we're going to do 4 times a times c. Okay, so 4 times 1 times negative 99 is actually going to give us a negative 396. Minus a negative turns to plus, and 2 times 1 gives us 2. Okay, so then we get x equals 9 plus or minus 81 plus 496 gives us the square root of 477 all over 2. Okay, and when we simplify 477, we find out that it's 9 times 53. 53 ends up being a prime, and so we can find the square root of 9. So it ends up being 3 square root of 53. So our answer is going to be x equals 9 plus or minus 3 square root of 53 all over 2. And remember, we can split that answer up because we've got two answers. 9 plus 3 square root of 53 over 2, or 9 minus 3 square root of 53 all over, 53. Square root of 53 over 2. Okay? All right. Nice job.